textbook, but it talks a little bit about oxidation numbers and balancing those, figuring out oxidation numbers in a molecule. And then I think you do a little bit of balancing redox, if I remember correctly. In case, in chapter 20, this next exam is going to cover sections 1 through 4, not beyond that. And the review somewhat. Okay, so figuring out oxidation states or oxidation numbers. So I apologize for like the wall of text here. But this is, you will need to know how to do this. So make sure you practice these problems. Okay, and I know that these can be tricky. We forget how to do this often. Okay, but there's some rules to follow here for figuring out oxidation states for various atoms. So if we have a pure element, the oxidation number is 0. Okay, so something like sodium or silver or copper, something like that, is 0. Oxidation number of a monatomic ion is equal to its charge. So for instance, zinc 2 plus has an oxidation number of +2. Okay. And it's crooked again. Okay. All right. The third rule says that the sum of the oxidation numbers in a compound is 0 if it's neutral, or it's equal to the charge if it's an ion. Okay? So when you sum up all the oxidation numbers for the atoms, it has to equal its charge, or if it's neutral, then it's 0. And there's a way to figure out what those individual atoms are in the formula using rules 4, 5, and 6. In rule 4, it says that for alkali metals, the oxidation number is +1. So we're looking at our sodium, potassium, and so on. Alkaline earths, +2, magnesium, calcium, 2+. For fluorine, it's always going to be -1. That's a nice rule. Okay, so in rule number 5, for hydrogen, it's almost always +1, with a couple of exceptions, and that is H2, because that is the naturally occurring sort of pure element. We're going to give that 0. And for ionic hydrides, H is going to be -1. So in that case, rule 4 dominates. So if we have sodium hydride, sodium is +1 and the hydrogen is -1. Oxygen, most of the time, is going to be -2. There's a couple of exceptions. Oxygen, where oxygen is 0. Peroxide, such as hydrogen peroxide, H2O2, oxygen will be -1. Okay. And then for other elements, so essentially we need to know sodium, we need to know our alkaline metals, our alkali earths, hydrogen, oxygen, and fluorine, and everything else we're going to base off of those things. All right? That's rule number 7. Okay. So work with your neighbor, write out the oxidation numbers for each element in these formulas, and then we'll check back in and make sure we got them right. All right, so for nitrogen monoxide, we know that oxygen has to be -2, has an oxidation number -2, which means that nitrogen must be +2 because it has an overall neutral charge, so those have to add up to 0. In NO2, again, oxygen is -2, but we have 2 of those, so that makes a difference, which means, and we have this overall 0, the neutral charge, so these oxidation numbers have to sum up to 0. So that means the N has to be +4. Did we get that one? Okay, good. Nitrogen can have different oxidation numbers, okay? Yes. SO4 2-. Again, oxygen, -2. We have 4 of those. So I'm going to do this. 4 times -2 equals -8. We have an overall -2 charge. And so overall -2. So we need to get our sulfur to add up to -6. There's 1 of those. So sulfur has to be -6. Did we get that one? Or +6, sorry. Did we get that one? Okay. And then, all right, let's do our potassium chromate sol, dichromate. Potassium is going to be +1. And there's 2 of those, so that's a total of +2. I'm going to put that in parentheses. Oxygen, of course, -2, and there's 7 of those. So that's -14. And then we have chromium, which we don't know, but there's 2 of those. And they all have to sum up to 0. So I'm going to have +2 plus -14 plus 2x equals 0. And what does that mean x has to be? So chromium has to be +6. All right. Are we remembering this stuff? Good. Okay. I think we will stop here.